Hello, everybody. I'm super excited to be here to present our new product, Hepic Cloud, and indeed the challenges of building an RTC architecture in the cloud and how it is going for us. So this is the lineup for today's presentation. I will start by introducing myself, then I will introduce our products, which hopefully will need no introductions because maybe you are already using them. Then we will discuss everything about Hepic Cloud, the challenges we faced with the architecture, everything that went down, then the lessons we took from it, and Hepic Cloud version 2. So, I am Rita, I am Portuguese, and I work at QXIP as a lead engineer and director of Cloud Ops. I have a master's in electronical and computer engineering, and my master's was mainly focused on telecommunications, and my dissertation was about network-driven and over in 5G. So back then, I was focusing on the radio side of telecom. And my first job was during my master's final year. I was an assistant teacher of C programming language. And while I was writing my dissertation, since I love telecommunications and I didn't want to become a programmer, I started to work on a CPaaS company as a VoIP engineer. And this was the place where I heard about and started to work with Homer, Kamailio, FreeSwitch, OpenShips, and all these tools that we all love and use. So I've been on this world, the VoIP world, for almost 5 years now, and last summer was when I joined QXIP to work on a different perspective on VoIP, telemetry, reports, statistics, and all the tools that a VoIP engineer needs. So back to our products, I wanted to ask you guys who is using Homer, if you can. Nice. And is anyone using Hepic here? Cool. Okay, so as you can see, maybe they don't need to be introduced. But before we proceeded, I wanted to say to you guys that we have many other products other than these ones that we are most known for, and that all the products have the same motto. If we can have you guys spare some time and money using our observability tools, then we are doing a good job. Also, all our products are interchangeable and there is no vendor lock-in. This means that if you are using Hepic and you want to switch back to Homer, you are always able to. Now, just because I know some people are new here, I wanted to say that Homer is our original product and how everything started for QXIP. So Homer is a framework for monitoring and analyzing VoIP and RTC traffic from any capture agent. This means that Homer is vendor agnostic, has an intuitive UI, and the best part is that Homer is an open source product, meaning it is 100% free. So Homer would be suitable for companies that indeed need a VoIP and RTCP monitoring system, and typically these companies have a highly skilled engineering team. And these engineers, typically, besides being skilled, they have the time on the roadmap to customize Homer according to the company's needs and expectations. So they would be DIYers that really love and contribute to the open source community. And I wanted to take this time to highlight that we are on Homer version 10, and version 10 has a lot of new cool features that maybe you want to check out. Namely, you can now have eBPF metrics inside Homer from your capturing agents. This is powered by our other open source product, RTC agent, and also you can have much more than just calls. You can have logs, telemetries, and statistics, and this is powered by Querying, another open source product that we have. And now let's take a look at Hepic. Hepic is the paid and evolved version of Homer, so it is not an open source product. And it was born because some big companies do not allow for any GPL code at all, no matter how good or bad it is. Also, Hepic would be suitable for companies that need a VoIP and RTCP monitoring system, but that also need RTP analytics. And guys, this is the biggest difference in terms of functionality when comparing Hepic with Homer, is that on Hepic you have RTP analytics, whereas on Homer you just have RTCP. Also on Hepic, we support you during all the process. So we support you during the installation, configuration, and for all the time after it. So we have a 24/7 support with an SLA. And now we arrive to the topic of today's presentation, which is Hepic Cloud. So, as the name suggests, Hepic Cloud is the cloud version of Hepic On-Prem, and it supports all the same features than we have on Hepic On-Prem. So the question is, why should you care for this new product? And the answer is that we are targeting a slightly different type of customer. So Hepic Cloud would be suitable for customers that indeed need, that have a distributed architecture, high traffic volume, and where the cost of scaling and maintaining an observability stack across all the regions is simply too high. So on Hepic Cloud, we are trying to simplify your observability stack to the maximum, because here you are just responsible to ingest traffic and that's it. We take care of everything else. And what this means is that we are the ones responsible for doing deployments, upgrades, service health checks, and everything in between. So you no longer need to accommodate on your roadmap to do these activities. You just need to ingest the traffic, go to the Hepic UI, and start troubleshooting, which is what actually matters to you, troubleshooting the traffic, and that's it. Now, Hepic Cloud is hosted on the cloud, so this means you need to ingest the traffic through the internet. Is it safe? Yes. We have end-to-end encryption, so your HAP packets would be flowing through TLS, and we provide a secure API and UI access. Also, on Hepic Cloud version 2, we are cloud agnostic and vendor agnostic, and we provide external integrations with Grafana and Quirin. Furthermore, if, for example, you are an AWS customer, you want to have your bring your own storage options with Hepic Cloud, we are compatible. That is possible. Okay, so, oops, too soon. Okay, so as I said, we are on Hepic Cloud version 2. And between version 1 and version 2, we had a performance increase of around 75%. So the user experience really felt it, and the best part is that the motto of the product remains untouched. So it is still as simple as it always was. You are still only responsible for ingesting the traffic. So this means that you would be ready to go to production within minutes. And with all these new features and such a performance increase, we got brave and we thought, okay, let's try to have an AI feature with Hepic. And we managed to do so. So you could have sentiment analysis with Hepic, and we achieved this using all the things open source. Just to prove you guys that for you to have cool AI features on your architecture, you don't need to invest a lot of money. Actually, you don't need to invest any money. We achieved this with just our time, which, well, it was a lot of time, so maybe let's take a look at Signals Wire's APIs, because I know they are cool and they do sentiment analysis in real time. But okay, just for the point that open sources can make it happen as well, we used RTP engine with the recording feature enabled to record the audio. Then we used our own open source repo, Speech to Hap, and the responsibility of this repo is translating this audio into text using Whisper, and then encapsulating it inside the HAP packet to send to either Omer or Hepic. And then for the sentiment analysis part, we use the npm.js sentiment. And, well, as you can see here on the screenshot on the right, you see that the sentiment analysis can be seen inside the call flow, and it is being sent as a log. And you can see that on this example, the scoring is -1, negative. And on the calculation, you can see the reason why. It's because for this sentence, there was the word stop that has a negative sentiment. And indeed, stop can be negative, but it can also be neutral depending on the context. And because of that, we included the transcription. So the whole sentence is here for you to see and interpret depending on the context, if it is indeed a negative sentiment analysis or just neutral. So another thing that you can do with this is that, let's imagine you want to see sentiment analysis for the past 5 minutes, regardless of the call ID. That is also possible. You would go to the UI, search for the logs for the past 5 minutes, and that's it. Click on anyone that you would like to see. This is the example on the left, the screenshot. And you can see that the type of details you get are the same. And if you feel like this is too much, because this is all that you are getting, if you feel that this is too much, you can customize this on the UI to just present what you consider to be important. And if you want to know how to achieve this on a step-by-step guide for your architecture, then join us on Thursday's Lunch and Learn, because Yachan will walk you through each step of the way. And well, finally, we will arrive to the juicy part of today's presentation, which is architecture. Because you may be thinking, well, it's a new product and we are on version 2. Why? Well, the reason for that is because we did some mistakes when defining the architecture of Hepic Cloud. And those mistakes led to product instability and down the line resulted in an architecture redesign. And, well, sometimes it may be easy to disregard the importance of architecture because there are almost infinite ways to achieve a working product. So sometimes it's easy to just proceed and put the product out there and see what happens. But to prove the point that architecture is indeed crucial to have a working product, before we jump into Hepic Cloud version 1 and all the issues that happened, I wanted to show you guys a more relatable scenario, I think. From my perspective, I believe everyone here is been into this situation of decided between using a message broker with a publish subscribe with a topic or a peer-to-peer messaging with queues. So let's imagine that we have a CPaaS scenario and someone registers on the platform and tries to make the first call, starts preparing for that. So right there you have a producer of data, the registration, the numbers purchased, all the outbound routes to make the calls, and so on and so forth. And then you would have a lot of consumers for the call to work inside your CPaaS. To name 3 examples, let's imagine you have billing, routing, and analytics. So the question is, should you use publish subscribe with a topic or peer-to-peer messaging with queues? I wanted to start explaining the publish subscribe because message brokers are super popular in the community right now, and probably for a good reason. So one of the good reasons is that if you want to add a new consumer, it comes almost for free on this type of approach. Let's imagine that you wanted to add a consumer named Numbers. Like, this comes easily. You just, for example, the producer, you don't need to touch it at all. It doesn't care. It doesn't even know that this new consumer enters the chat. You just need to publish a new topic, develop the number of consumers, of course, and say on its code that, hey, you need to subscribe to this topic, and that's it. So the extensibility is almost infinite, and it's really easy to achieve. Another good point of this topology is that since the producer is agnostic of the consumers, this means that the code of the producer is made once and you can forget about it. Like, it maintains itself. It doesn't need to be touched ever again. So, well, we are indeed using message brokers with good reasons. Like, this approach is easy to scale and easy to maintain. 2 of the biggest features that we are all looking for nowadays. So the question is, why are people using peer-to-peer? And, well, to make the side-by-side comparison, let's imagine again that you want to add the numbers consumer. Well, on this approach, it doesn't come for free, because you need to adjust the producer to send a new and dedicated message to this new queue that you need to develop and handle, because it didn't exist before and now it needs to exist. And then the numbers consumer, of course, you need to develop that as well. So the question remains, why are some people choosing this approach? One of the good reasons may be data security, because since the producer sends dedicated messages for each consumer, this means that you have fully control of what information reaches each consumer. So let's imagine that there are credit card numbers being exchanged on the calls. Probably you would like to have fully control and to certainly know where that information is going. Because on the publish subscribe, it's the feature of this topology that any consumer can subscribe to any topic. So you cannot control by the architecture itself data security, whereas on a peer-to-peer you can. Another good point for this one is that since it sends dedicated messages to each consumer, this means that you send only the information the consumer needs, nothing less and nothing more. So if, for example, the analytics consumer would be gone from here, you want to remove it, you would go to the producer and say, hey, stop sending these messages because no one is caring for them no more. So this means that you are being mindful of the bandwidth. And this is really important because in distributed computing systems, we all know that we are using specs and resources as if they were infinite, but that is simply not true. On the publish subscribe, for example, the producer sends the same messages always and forever. So it could be that in the near future, you are sending these messages with a big chunk of information that no one is caring for. You are wasting bandwidth. And we all know how hard it is to recover from a scenario where you are saturating the bandwidth. And then lastly, good point for peer-to-peer as well, is that it has queues. And this is important because if a consumer is getting overloaded, you can clearly see it, and you can monitor the queue, each queue, and you can scale vertically or horizontally the consumer, depending on your scenario, and you can automate that decision. It's really easy. It comes out of the box almost. Whereas on the publish subscribe, since it's just one queue with topics, of course you can detect if there are consumers getting overloaded, but it's not that easy to automate the scaling. So again, which approach, now that we looked into all of this, should you choose? And the only right answer is that it depends. And it depends on the trade-offs that are important for you, for your product, and for your architecture. Like, do you deal with sensitive data? Are you expecting to scale up the consumers? Is the nature of the product that the consumers may change in the future or not? Like, answering these questions and a lot more is what enables you to properly analyze the trade-offs and make a conscious decision. So hopefully now you understand why failing to analyze these trade-offs is bad news. Which, well, was what happened with Hepic Cloud version 1. So let's see what happened there, and let's start with the good parts. And the good part was for sure Kubernetes, because we are developing a new product on the cloud, so of course we took a look on Kubernetes, and well, we found ourselves amazed, because what's there not to like? Kubernetes is highly dynamic, auto-scales and descales, self-heals, has a native load balancer to improve the performance. Sounds great. And furthermore, it is open source and vendor agnostic, two features that we treasure the most at QXIP, because we are, after all, an open source company. And then we thought, okay, on Hepic on-prem, we already support having the services inside Docker containers. So Kubernetes is an orchestrator of container runtimes, so it's decided we go with these Docker containers inside Kubernetes, and it should be a smooth transition. Well, but that's where we failed, right? Because with all Kubernetes advantages, there are many trade-offs. And the biggest one that we overlooked was the learning curve. Because thinking that, I mastered Docker, I understand everything about Docker, so Kubernetes should not be that different. Well, that's a huge mistake. Because with Docker, no architecture topology is enforced to you, whereas on Kubernetes, you need to go into microservices. And on Hepic on-prem, we were a service-based architecture, so we are talking about moving into one of the hardest architecture topologies on the market, which is microservices. And we are not comfortable with Kubernetes itself at all, because suddenly we need to master concepts as CI/CD, infrastructure as code, cloud-native topologies, and all of these new big words that, well, how can we do that right now? Basically, we either train the team that we have, or we hire new people, proper DevOps engineers that really know these concepts and are familiar with them. Either way, the cost is considerably high. Furthermore, what happens when you have such a dynamic architecture that auto-scales and descales, is serverless, and can work in AJ mode, but your code is not ready for it? Basically, you need to work hard and adjust the code. So this is a lot of work. But it didn't end there. So it got worse, and the decision that really well, did not age well was going with AWS. Because, as I said, Kubernetes is vendor agnostic and open source. Amazing. And then we decide to put it into a cloud provider that is one of the most expensive ones out there. Why? Well, because managing Kubernetes by yourself is hard. And there is not a lot of people that can do it well. And as you probably know, AWS has a native option for you to run your Kubernetes, where they care for the Kubernetes control plane. They are managing it, providing it, and you just need to focus on the rest. But as we saw, the rest is not that simple either. And as you also know, probably AWS pushes you into their own options. So we are talking about a new product. So of course, we are changing things around, trying to add new features, and so on and so forth. And when you go with AWS, they kind of push you into their own products and solutions for these type of challenges. And well, nothing on AWS comes for free. So the bill at the end of the month was getting hard to justify. And while we were facing those challenges with AWS, we were also taking a huge hit on the product performance. And this is because, as I said, Kubernetes auto-scales and descales automatically. But it does it based on rules. You either define those rules or you automate the decision. And we were not ready to make the decision ourselves because we are trying to nail this architecture. So we are not ready. And furthermore, we are talking about a highly dynamic architecture with an RTC product. So the levels of freedom are almost impossible to predict. So we thought, okay, many people on the community are using Fargate and Carpenter. Let's try them out. They are not exclusive to Kubernetes, but they are widely used. And for sure, they were doing its job. Like, there's nothing to point out to them. They work great. But the issue was, again, that the code was not ready for it, simply. So as you can see, the aftermath is not looking great. So we needed to sit down and really think about it. And the decision was to drop AWS and Kubernetes altogether. Because what's the point? What are we trying to achieve? And we concluded that at the moment we were trying to build a house starting on the roof. And that doesn't work, simply. So these were the main deal breakers for us, and they were all connected because, well, the root causes are the same. First and foremost, the cost. Hiring people, training the team, changing from a service-based architecture into a microservices one. And the bill of AWS was really unjustifiable. Then the performance, because moving into microservices means that you need to split some functionality. It's part of the work. And some splitting that we did added more latency than what we were expecting. But that was not the biggest hit. The biggest hit was, of course, automating the elasticity and scalability when the code was not ready. And at the end of the day, it all came down to simplicity, because managing microservices architecture is hard, is a challenging in itself, and doing that on the job with a small team was painful. So again, we sat down and we redesigned the whole thing, and we landed on a Docker composed scenario, and Hepic Cloud version 2 was born. And yeah, let me tell you that I've been sleeping much better now. So right now, all the services are inside Docker containers, and each customer has a segregated setup with dedicated resources. We are now cloud agnostic and vendor agnostic, and we can discuss and accommodate for any customer request and concern because, again, it is a segregated setup. So if a customer has a dedicated need, we can accommodate without fear for the stability of others. And the best part is that there is no restriction imposed by the architecture because Docker doesn't force you to go into any type of architecture. So right now we managed to have Hepic on-prem and Hepic Cloud both on a service-based architecture. And well, this is the architecture that we have right now on Hepic Cloud. So As you can see, anything purple was developed for Hepic Cloud. Hepic metrics can now be used on Hepic Cloud and Hepic On-Prem. Then we have orange for external integration with Quirin, yellow for external integration with Grafana, and green for what came along directly from Hepic On-Prem towards Hepic Cloud. So a lot of new code and adjustment and changes. So sharing our this part of our history today with you guys made all the sense to us because we are strong believers on the community's empowerment to all work together, share the lessons learned, and improve together. We are an open source company after all. And between all the lessons learned that we took, I wanted to highlight two today. And first one is just because there is a new shiny thing on the market, namely Kubernetes, it does not mean that we all should go for it. It also doesn't mean that people using it are wrong because, again, different products have different trade-offs. Second lesson learned is just because it was not a match for us at the moment, it doesn't mean that it will always be wrong, because products change, requirements evolve, and it could be that in the future we go back to Kubernetes and it will make sense, but it's just not the time. And yeah, thank you for having me today, guys, and for allowing me to share this story. Thank you.
We do have time for just one or two questions, Rita. So let's see. Has anybody got any questions that they would like to ask Rita about this work that they've been doing, or any challenges that they faced? I'm not seeing any. Oh, sir, you've been doing very well for questions. Well done. I'm going to give you an English chocolate for asking a question as well.
Chocolate. I'll share my chocolate with you. Okay.
Thank you.
You're welcome. Okay, so you mentioned AWS for your Kubernetes instance. Mm-hmm. Who's running your Docker containers? Is AWS running your Docker containers?
No, right now we are doing it ourselves. So on a segregated setup, on dedicated nodes.
So is it Kubernetes or is it AWS you're talking about?
No, it's Docker. Now just Docker, no Kubernetes.
No, I know. Okay, I understood. So it was the external hosting costs that were the flipping point for you to go off Kubernetes.
One of them. The other one was trying to do Kubernetes without knowing what we are doing, I would say.
Thanks on honesty. Points for honesty.
Thanks for sharing. Very good. Thank you.
Thank you.
Thank you. Okay. I don't see any more questions. Oh, yes, I do. Mac's got a question.
Yeah, I do. So did you think about any other orchestrators to use? Let's say, for instance, HashiCorp has one called Nomad. Did you think about one of those, which is much simpler? You don't have the complexities of Kubernetes. Anything else was thought about from an orchestration perspective?
Yeah, thank you for your question. Actually, yes, I navigated those. But just for the purpose of the product and what we are trying to deliver, we thought that for now, it would not make sense because the most important point for us for the product is deliver the segregated setup and dedicated resources. At least for now, that's the type of product that we are trying to go for, but maybe in the future, and depending on the demand of the customers, probably.
Thanks, Mac, and thank you. Okay, let's say a big ClueCon thank you to Rita.